Welcome to our planet, 252 million years ago, a time of unimaginable upheaval where life itself teetered on the brink. This is the story of the Permian-Triassic Extinction Event, more starkly known as the Great Dying. This wasn't just another extinction event, it was the most catastrophic event in Earth's history. Imagine, if you will, a world where 90 to 96% of all life in the oceans vanished. On land, 70% of vertebrate species disappeared, entire ecosystems collapsed, leaving behind a desolate and silent world. Join me now as we journey back to this pivotal moment in time. Let's explore the cataclysmic forces that reshaped our planet and forever altered the course of life on Earth. Our story begins deep within the Earth's crust, where unimaginable forces were building. In what is now Siberia, a vast volcanic system known as the Siberian Traps began to stir. This wasn't your typical volcanic eruption, with towering cones spewing lava and ash. This was something far more insidious, far more devastating. Over a period of perhaps a million years, these fissures in the Earth's crust oozed out unimaginable quantities of molten rock, blanketing an area the size of Australia in layer upon layer of basalt. But the true horror lay not in the lava itself, but in the gases it released. Carbon dioxide, a potent greenhouse gas, poured into the atmosphere, trapping heat and causing temperatures to climb. But that wasn't all. Methane, another greenhouse gas even more potent than carbon dioxide, was also released in vast quantities. The Earth's atmosphere was becoming a furnace, and the planet was about to experience a fever the likes of which it had never seen before. Imagine, if you will, the skies darkening as volcanic ash choked the sunlight. Temperatures soared, rising by as much as 8 to 10 degrees Celsius. The once lush and vibrant ecosystems of the Permian began to wither and die under this relentless onslaught. The Siberian Traps were a wound in the Earth's crust that refused to heal, spewing forth its deadly cocktail of gases for millennia. The very air itself was becoming toxic, setting the stage for a cascade of catastrophic events that would push life to the very brink. As the Siberian Traps continued their relentless outpouring of greenhouse gases, a terrifying phenomenon took hold: a runaway greenhouse effect. The Earth's natural systems, which had always maintained a delicate balance, were overwhelmed. The surge in carbon dioxide and methane trapped heat, causing global temperatures to rise at an alarming rate. This, in turn, triggered a series of feedback loops, each one amplifying the warming effect. The hotter it got, the more unstable the climate became. One of the most devastating consequences of this runaway warming was the melting of methane clathrates. These icy deposits, locked away in the ocean floor and permafrost, contain vast amounts of methane. As the planet warmed, these clathrates began to thaw, releasing their potent cargo into the atmosphere. Imagine the oceans bubbling as methane, a greenhouse gas many times more potent than carbon dioxide, escaped from its icy prison. The atmosphere became thick with these heat-trapping gases, further accelerating the warming trend. The Earth was caught in a deadly spiral, and there seemed to be no end in sight. The consequences of this runaway greenhouse effect were felt across the planet. Oceans became warmer and more acidic, disrupting marine ecosystems. Weather patterns became erratic, with intense storms and prolonged droughts becoming more common. The once stable and life-sustaining climate of the Permian was collapsing, and with it, the foundations of life itself. As the Earth sweltered under an increasingly toxic atmosphere, the oceans, those cradles of life, were also undergoing a terrifying transformation. The very waters that had nurtured life for eons were turning against their inhabitants, becoming both acidic and devoid of oxygen. The warming waters, unable to hold as much dissolved oxygen as before, became increasingly suffocating for marine life. Imagine the once teeming coral reefs, now desolate graveyards, starved of the life-giving oxygen they needed to survive. Fish gasped for breath, their gills unable to extract enough oxygen from the depleted water. But the horror didn't end there. The excess carbon dioxide in the atmosphere was also being absorbed by the oceans, leading to a phenomenon known as ocean acidification. As the pH of the water dropped, it became corrosive, eating away at the calcium carbonate shells and skeletons of marine organisms. Imagine the plight of creatures like trilobites, their once sturdy exoskeletons dissolving in the increasingly acidic water. Coral reefs, already struggling to survive in the oxygen-depleted water, crumbled before our eyes. their intricate structures dissolving into the increasingly hostile sea. The once vibrant and diverse ecosystems of the Permian oceans were being decimated. From the smallest plankton to the largest marine reptiles, life was being extinguished on an unimaginable scale. The oceans, once teeming with life, were becoming silent, acidic tombs. As if a runaway greenhouse effect and suffocating oceans weren't enough, the Siberian Traps unleashed another horrifying consequence: toxic rain. The immense volcanic eruptions spewed out vast quantities of sulfur dioxide, a gas that combined with water vapor in the atmosphere to form sulfuric acid. Imagine, if you will, a rain unlike any other falling upon the land, scorching plants and poisoning the soil. This acid rain stripped trees of their leaves, leaving behind a skeletal landscape. The once fertile soils turned acidic, making it impossible for many plants to survive. But the source of the toxic rain wasn't limited to the skies. The dying oceans also played a role in this toxic onslaught. As marine life perished in the oxygen-depleted waters, their decaying bodies released hydrogen sulfide, a poisonous gas, into the atmosphere. Imagine the stench of death rising from the oceans, a grim testament to the scale of the disaster unfolding. This hydrogen sulfide, combined with the sulfuric acid rain, created a toxic cocktail that poisoned the air and water, leaving few places on Earth untouched by its deadly reach. The ozone layer, Earth's protective shield against harmful ultraviolet radiation, was also under attack. The massive release of chlorine and bromine-containing compounds from the volcanic eruptions further weakened this vital shield, exposing life on Earth to dangerous levels of UV radiation. The combined assault of acid rain, toxic gases, and increased UV radiation created a hostile and unforgiving environment. Life on Earth, already struggling to cope with a rapidly changing climate and suffocating oceans, now faced a new and deadly threat from above. The interconnected web of life began to unravel as the Great Dying tightened its grip on the planet. Ecosystems crumbled, food chains collapsed, leading to starvation and extinction. Herbivores faced a barren wasteland as plants withered and died. With their food source gone, many couldn't adapt. Large herbivores vanished, their populations decimated. Carnivores, deprived of prey, faced starvation. The mighty gorgonopsids saw their reign end. These saber-toothed hunters were doomed. Their size and strength were no match for extinction. Even insects weren't immune to the Great Dying. Many insect species perished. The balance of life was disrupted. The collapse of food chains showed the interconnectedness of life. When one thread breaks, the entire tapestry is threatened. The Great Dying demonstrated this principle, leading to the demise of countless species. The Great Dying wasn't caused by a single catastrophic event, but rather by a perfect storm of multiple stressors, each one compounding the others, pushing life to the very brink. It was a confluence of unimaginable volcanic activity, runaway climate change, and ecological collapse all happening in a geological blink of an eye. Imagine, if you will, a world where the very air you breathe is thick with toxic gases. The rain burns your skin, and the sun scorches the land. The once fertile lands have transformed into barren wastelands, and the oceans, once teeming with life, are now silent, acidic tombs. The Siberian Traps, with their relentless outpouring of greenhouse gases and toxic chemicals, set in motion a chain reaction that would have devastating consequences for life on Earth. The runaway greenhouse effect sent temperatures soaring, disrupting weather patterns, and pushing ecosystems beyond their limits. The oceans, absorbing the excess heat and carbon dioxide, became warmer, more acidic, and increasingly hostile to life. Marine organisms, already struggling to survive in the oxygen-depleted water, faced a double whammy of acidification and suffocation. On land, acid rain poisoned the soil, stripped trees of their leaves, and transformed once lush forests into skeletal graveyards. Toxic gases filled the air, making every breath a gamble. The ozone layer, weakened by volcanic emissions, offered little protection from the sun's harmful UV radiation. The Great Dying was a stark reminder of the fragility of life and the interconnectedness of Earth's systems. It was a time of unimaginable upheaval, a time when the very foundations of life were shaken to their core. In short, the Great Dying was so catastrophic because Earth's climate, oceans, and ecosystems were hit on every possible front, and it happened very rapidly in geological terms. Life on Earth had never experienced anything like it before, and it would be millions of years before our planet recovered from this cataclysmic event. It took millions of years for life to recover, and the survivors shaped the course of evolution, eventually giving rise to groups like the dinosaurs. The Great Dying serves as a stark reminder of the power of nature and the importance of understanding the delicate balance of our planet's systems. Would you like me to also show a timeline graphic of how the extinction unfolded? Perhaps a visual representation of this catastrophic period would help to comprehend the sheer scale of this event and its impact on the history of life on Earth.